Anyone like heard about Polkadot before? Yeah. I mean, this guy doesn't know anything about Polkadot. Learning, right? We're learning. We're all learning. I gave an intro to like all these workshops that we're going to be doing throughout the week, and really like what I want to encourage is a space where people are asking questions. Nobody has a dumb question, right? And for this intro, we're gonna try to get some questions answered. I'm going to try to give you where I think Polkadot is at, and give you my way of trying to introduce you to Polkadot. So this is a picture of nodes spread across the globe. If you go to this link, which you don't need to do, but you can if you want, you'll see that there's all these validators that are doing work for the network. Polkadot is also a network with a lot of capital locked into it to give it the security it has. So right, like on this slide, we're looking at it's a screenshot from an app called the Staking Dashboard. Which if you go on this link, you'll check it out. You can find it for yourselves. And what we can see here, oh, I have pointer, amazing, is that I took this yesterday, and there's currently 989 validators on Polkadot, with a total of over 745 million dots staked, and information about pools and active bonds and nominators. What does that information tell us about Polkadot? That it's a what kind of network? Blockchain network? Decentralized? Yes. But what does the information about it's got validators and nominators tell us about Polkadot? It's a nominated proof of stake network. So good, we learned something about Polkadot already. Like we were trying to say, like, what is Polkadot, right? Polkadot is also an innovation playground, and it's really it's a place where we want to experiment with maybe crazy ideas for blockchain applications, and it has its own canary network to do that. It's called Kusama. So Kusama is this canary network where before putting on applications or upgrades to core network protocol stuff on Polkadot, well, we maybe want to try it in a setting where there's less at stake, right? There's less risk with putting whatever that would be on like the main network, right? Polkadot really is the main network. It has a canary network called Kusama with real economic value, which is a cool feature of Polkadot, right? So Polkadot is also a place to experiment things as a whole, right? Kusama can allow you to do that before putting your crazy idea on Polkadot. Maybe try it out Kusama. And Kusama has a lot of cool features to enable you to do that, such as you have much lower fees, deposits are lower, and it's almost like it's okay if things break on Kusama. That's kind of the branding of Kusama. So there's over $5 billion staked on Polkadot. So we're building up this idea of what is Polkadot, right? So that's more than half the supply of DOT, right? So we've said Polkadot is decentralized. It's a nominated proof of stake network.
Oh, okay.
And there's over $5 billion securing it. So it's not bad, right? We're in a place where over half the supply is actually locked into the consensus protocol. That means that it's got elements indicating like strong security, right? We could say. This is just a screenshot of the core developer behind the staking dashboard, and he's just kind of touting that the total supply staked has increased from what was it by 0.16%. This is indicative of a healthy protocol and a healthy network
in the light of the security that it provides. So we say Polkadot is decentralized, it's resilient, it's censorship resistant, and it's secure. We can dive a little deeper into the resilience aspect and censorship resistance as we proceed. And I want to highlight what like this specific talk wants to focus on, which is two elements in Polkadot's design to achieve what it wanted to achieve from the beginning, which is scaling the decentralized web. Right? We needed a better mechanism for scaling all these applications that Ethereum was simply not able to handle back in 2016. So the design goals kind of fall into a bit of philosophy, I would say, that we can go into that a little later. But the core things is that we need blockchains to be specialized. So you can't have blockchains that are trying to do everything. Right? You can't have like a completely generalized piece of machinery that can take in any type of application. Or of course you can, right? But that design might not be conducive to actually scaling and having a Web3 application layer that isn't maybe constantly congested if it's all running on the same underlying protocol. So having specialized chains, we're going to talk about, and then we're going to talk about the second thing, which is future-proofness. That kind of goes into the philosophy stuff. So let's dive in. I find it very important always to just do a terminology check, where we might be throwing around words that nobody's ever heard about before. So anyone heard about the word Blockspace before coming to this event? Obviously. Yeah. What's Blockspace? Like what? Because the other thing, and why it's cool that we're at an ETHDenver side event right now, is that a lot of ecosystems kind of share the same terms, or share the same things that they want to say, but with different words. So for me, Blockspace is the resource that is produced by a blockchain. In our context, it's the raw material, the raw resource that Polkadot produces. Okay, cool. The relay chain is another term we might come across. The relay chain is, in Polkadot world, it's this layer 0, which is the blockchain that's dedicated to providing the security to the chains that connect to it. We'll also come across another term called parachains. Parachains are the specialized blockchains, aka app chains, aka application-specific blockchains, aka layer 2 chains in Ethereum world. Yeah, cool. Make sense? Yeah. So and then I do want to like double click on these terms. For instance, in Ethereum, the relay chain really equates to the beacon chain. There's the protocol upgrades in Ethereum right now are really honing in on beacon chain being used to validate shards that are sending state to be re-executed and validated, such that that state then cannot be reverted. We have the similar thing, right? Where in Polkadot, it's a relay chain that's doing that work, but instead of calling them shards or layer 1s or layer 2s, I should put in there, because I think more Ethereum people will talk about beacon chain being layer 1 and then layer 2s are app chains. You know what I mean, where it gets a bit of a kind of a it gets a little messy, but that's my point in double clicking here, is that I just want to be on the same page. What we're talking about, very similar things, but in different ecosystems, we have different ways to call. We have just different names for them. So parachains equates to shards, layer 1s, 2s, which really is modular blockchains, right? This is overhyped now. Everyone's talking about having modular blockchains, easy way to create rollups, like rollups as a service, like frameworks that help you create rollups, etc. And and they use the relay chain, or in Ethereum's world, the beacon chain for finality. I put this in because there's an ecosystem agent, let's say like somebody that's very active on Twitter called Goku. He's amazing. You should follow him. And he's very bullish on being like, but guys, like, we've been doing this on Polkadot since 2019. Like, so you've got, again, like similar terms, shared sequencing, proving, that's what the relay chain does. Composability and interoperability, we call that XCM. Rollup frameworks, it's this thing called Polkadot SDK that is more commonly known as Substrate. Again, we're doing the same kinds of things. Polkadot has been designed from day one to do those things, though. This is another meme, but it's very memey. Like, so anyone finding these, like, I think it was recently someone published what was supposedly an email thread with Satoshi in the early Bitcoin days. No, no. Am I the only one like that's in this corner of Twitter? Daniel, you saw this stuff?
Yeah, I read it that it was like the early, sorry,
Yeah.
the early email thread of Satoshi with, I don't remember one of the collaborators, and it was like basically talking about design stuff, and also like he put like most of his life on the project. But
But there's a real. I assume they're real threads, right? And I think I saw the same one. It's like Satoshi asking for help to make the website. I read that one. But there's a bunch. There's a thread. But right now, you're fine on Twitter. People are kind of mocking the thing, and like this is a funny one because it was made by Goku actually. Yeah, if anyone comes up with a new blockchain with low quality block space and it claims to be super fast and scalable, it's toxic. Stay far away. Look for the first class scheduling. Look for efficient block space allocation. Look for the shared security that becomes more robust as it expands for healthy block space. Look for blockchain that will do for block space what cloud architectures did for server space. If anyone tries to do rollups, shared sequencers, or rollup frameworks, then just know it's all Polkadot. I like to share a little bit of another kind of like thing in meme culture, I guess you could say. This was something I threw on the Twitter world. Welcome. Oh, come.
Trying to sneak around.
Yeah, this is another, like, so in Germany we have this concept of, wait, sorry, like our key term here is block space, right, guys? So we're still together, right? Like, Polkadot, the Blockspace. So Blockspace is important because that's what really Polkadot produces. But okay, here in Germany, we have labels like on if you're buying meat at the supermarket, right? If you're buying meat at the supermarket, you'd find this labeling system, and it's really, for me, it's this meat quality analogy. So there's 4 levels. The lowest level indicates the animal was kept in an indoor farm. Yeah, like whatever. You don't want to touch that chicken unless you're cooking for 50 people and you just can't afford the organic one. The second tier is what is it? Followed by indoor farming. Oh, it has a mix. So it's kind of like the chicken had a life a little bit outside of its cell, and then we were at like 3 and 4. Das ist Premium, ja. Das ist sehr gut, right? And the analogy here is that like block space is being produced by a lot of chains. Like, you know, Ethereum has really, really high quality block space in terms of its security guarantees, right? Because when we started here, I was just sharing like the amount of $1 billion worth that are locked in the consensus protocol Polkadot, which equates to security, right? It means that it is hard to attack that network unless you have that capital where you could potentially then create a new reality of the state of that chain, and you would need that. And so again, like a lot of other blockchains are producing block space, like that is the raw material. Why I show this is because there's properties perhaps that Polkadot has where we could say that this is Blockspace that has certain merits in the quality that it provides. I love the Solana ecosystem, and I like to bring it in as a contrast, because if I'm shopping for organic meat, I can afford it, and I have a goal, and I'm gonna like pay more for it, right? And whatever. If I'm gonna go shopping and I don't really care so much, like it's on me, right? I'm paying less, but I know what I'm getting out of it. And so this is what this analogy is about. Cool. So Polkadot, let's talk a little bit more about this key element of Polkadot, which is its future proofness. Yes. In order to get to the bottom of this all, we haven't mentioned a very important piece, which is the dot token, right? So the dot token it's a key component that is necessary to do the things on this vast machine, which is Polkadot. And it's important for mostly let's sum it up into these two things. So governance, the Polkadot token holders have control over the protocol, right? That means that dot holders can influence upgrades to the protocol. They can influence treasury spending. If anyone here was in my workshop earlier on Nova Wallet, we did this cool thing where we learned about like governance and stuff. And really, what's cool is that there is mechanisms to incentivize voters, there's mechanisms that you can have proposals on chain that if they're benefiting the network, they can get voted on. And if they're not benefiting the network, they can get voted on too. And there's this whole on-chain mechanism to help for the prosperity of Polkadot itself. And that's the dot token. That's one of the things you can do with dot. You can also stake, right? So staking is a really important part to keep the network secure, like we looked at in the beginning. So it's game theory incentivizes token holders to behave in honest ways. But on the flip side, if there's any misbehavior that the validators, don't there's a bunch of rules in consensus design, but essentially, if they act maliciously, if they are voting on two different chains, they get slashed. So there's an incentive to act honestly, and on Polkadot, we have a delegated proof of stake system, which means that we're also encouraging more participation in the staking mechanism, where anyone can participate in staking and get rewards with as little as $1. So that's kind of cool. That's a cool feature of Polkadot and its native token. Bonding is a other key utility of this asset. And the question of why would we need to bond tokens on Polkadot? There's several reasons why, but the main part is how to access this machine, which is Polkadot. How to use Polkadot as a service. Cool. Okay. Tuk. So future proofness. But I think I'm gonna just go over right into the next one after this. Zoe, yeah.
Yeah.
Because it's kind of all linked, and I would want to encourage more questions actually from the audience than me talking your heads off. Future proofness. Yes. There's this really cool feature about Polkadot is that it's designed to be upgradable. So think like if you have a software update to do on your phone, whatever, you can just do it, right? It's just software that is being updated and upgrading whatever your experience is, blah, blah. Same like a Tesla car, right? So this is what this slide is. We can upgrade the network. And these are very important decisions that are baked into the protocol that make Polkadot what it is today. this has implications not only on the features that you can have on Polkadot, but on the community too. Where in a lot of blockchain ecosystems, an upgrade might entail actually forking not just the network, but the community itself. Anyone own Ethereum Classic? That was a decision, that was the outcome of a decision that was made for reasons that we don't need to get into, but that resulted in there's two schools of thought about what we need to do about the network. One is we need this chain called Ethereum Classic. The other is we are going to continue on Ethereum. And anyways, it kind of forked the community. And this is very prevalent in blockchain days, like, well, very prevalent, I think you would say, in the time that Polkadot was being designed. So Polkadot has this beauty of upgrading the entire network without needing to hard fork. And the new features of the network essentially can be upgraded by being proposed through on-chain governance. I've said this, I think, a little earlier, that Polkadot is home to one of the largest on-chain DAOs that exists. And that's not a kind of afterthought feature. That is baked in because it is necessary for anyone to kind of propose things that can benefit Polkadot, or propose upgrades to the protocol and get voted on. And these mechanisms need to be very, very carefully designed, because you can't just be like, hey, I'm going to upgrade the main Polkadot chain with malicious code. There's mechanisms that we're not going to get into today, but in this introduction to Polkadot, this screenshot is showing a bunch of proposals that are doing certain things. Like there's a bunch of different categories. I'll leave room for questions. Yeah. So future-proofness, and the second piece is that Polkadot paves the way for a multi-chain future where we have specialized blockchains. And I want to double click on this because the notion of having specialized blockchains isn't just a scalability solution. It certainly is in the design of having shards, and the network isn't congested with all of the same applications using that network. But the beauty of it is that then you have application chains that are specialized in what they do, and that you as a developer don't need to reinvent the wheel on whatever, an Oracle system. You can use things like AccuRest, which is a parachain that exists on Polkadot. And so the specialization thesis really brought some really interesting things to Polkadot as a network. Yeah, I'm gonna go right into the other talk after this. I realize I'm at 30 right now. So Polkadot connects a network of custom-built blockchains. We've got specialized chains. Great, but what if they there's no use to having that if they can't talk to each other, right? So Polkadot is also a layer that enables sending messages between these specialized chains. The problems that we've solved with Polkadot so far is that it's now easy to spin up your own app chain. It's now easy to spin up your own app chain and make it connect to Polkadot, i.e. inherit the security that Polkadot provides. It's also now no longer a case where you have isolated chains that are like a lot of layer 2s right now, where layer 2 isn't necessarily designed to talk to another layer 2. In fact, you would need to rely on a bridge probably to do that. But baked in the protocol, we have this mechanism that allows interoperating between these chains. And there's another really cool thing about Polkadot, which is that if you want to launch your own blockchain, it's a huge cost, right? It's not just like, oh, I'm going to get a bunch of developers, create my own custom blockchain, and then launch it. What about the infrastructure costs? What about running validators? How secure is your network if you need to run your own validators, right? The beauty with Polkadot is that you can inherit Polkadot's security. And you don't need to run your own validators or create your own cluster of validators. So back to parachains on Polkadot. So these are the application-specific blockchains on Polkadot. There is currently 49 parachains on Polkadot. And there are two different types of chains. I want to highlight this because there's chains that use the native dot token. We call them system chains. These are chains that are, as Polkadot is developing, we're taking out the core components and features that are in the Polkadot relay chain, and we're making them their own app chain. We're making them their own specialized blockchain. And in the other category of parachains, types of parachains, there's all the other chains, all the other things that want to use Polkadot as a service. And those chains can permissionlessly connect to Polkadot. So essentially, the way that it works on Polkadot is that everything with parachain IDs 1000 to 2000 are reserved for these system chains, and then everything else can be anything. So if you check out polkadot.org, you'll see, actually, don't check that out. I have a workshop about but anyways, you can look at a block explorer and see these parachains yourself. Okay, so the last point I said is the beauty is that you don't need to run your own validators. You don't need to have that overhead cost, right? So Polkadot makes security easy for blockchain teams by allowing them to plug right into this Polkadot machine, this vast machine that provides finality and decentralized compute. And it allows them to focus on what they do best. Like imagine if you have a team of engineers who's developing this really cool app chain, and they have to worry about all this other stuff. Like, no, they can just focus on what they know best. So a little bit under the hood, let's check how this kind of all works, right? This is a visualization of the kind of machinery, like what actually takes place when we talk about the different nodes that are participating in the network. So essentially, on Polkadot, you have validator nodes, which are these guys here. So if I click here, I can see there's a validator node, and there's more of them than there are these blue guys. What are the blue guys, right? The blue guys, they are what we call collator nodes. So collator nodes are going to send blocks to validator nodes in order for the validator to run and execute the state of the parachain that the collator is from, right? So collators are parachain nodes. If you're a parachain, you're a rollup. You're sending your blocks to Polkadot, and this is what it like. I just want to show this visual because what we see here is the Polkadot relay chain creating a canonical version of irreversible history, and it's literally collator block gets sent, validated by validators, and then added to the block, added to the canonical chain. And there could be forks, or there could be unfinalized blocks. Look, kind of cool. Anyways, this is kind of like, as we're gonna just kind of look at what the mechanics of it all is. It's a nice little visual. So we've got a relay chain layer 0, parachains layer 1, and bridges. Bridges really, they can be smart contracts. They can be specialized parachains that are designed to bridge assets from other ecosystems, like Ethereum or like Bitcoin. And so essentially our diagram here has collators, we've got validators, and the relay chain, this Polkadot machine is validating and creating finality for these blocks. I'm going to skip over this, but essentially what I just said, right? We've got a cool mechanism to make this secure, right? It's called shuffling validators. Like validators are randomly assigned a collator. And because they're randomly assigned, it's really hard to attack validators. It's hard to censor transactions. But I'll leave people to ask questions towards the end. I don't need to really dive into this. I want to dive into this. Like, I'm very eager to dive into this. So what's beyond all this stuff? So right now there's a lot of conversation in the Polkadot ecosystem about things like core time, agile core time, core play, and all of these like new terms are coming up as we're slowly we're slowly framing or reframing what Polkadot really is and what it provides. And we know what it is. We know what it provides. It provides decentralized compute, verifiable, a way to verify state that's being sent to it. But really, what you boil down to it is creating Blockspace as a resource for other applications and app chains to use. And up until today, it's been kind of primitive, the way that resource is allocated and available. So it's been such that if you're an app chain, you need to say, okay, I'm going to use this resource for 2 years, and I'm going to bond some tokens to use this resource, and then after 2 years, I'm gonna renew my slot if I want to. It's called the slot-based or crowd loan model that has onboarded all the parachains that we have today. But it's primitive because it's not very flexible. It's not very agile. So there's really interesting things happening right now in this new wave of what Polkadot is and how it's going to be used, and that is making this resource more available to different dApps and app chains. Yes. Yeah, so the whole thing is it's a vision for a more flexible, ubiquitous computer. This introduction to Polkadot is what is it, right? We talked a lot about it in the beginning, but really it's a computer. It's an open, decentralized computer for verifying state of various state machines. We didn't talk very technical on this talk, but a state machine can be an app chain, but it could be anything that compiles to WebAssembly. So Polkadot just verifies a WebAssembly blob, and that's what the collator would send it. So the road ahead is making this ubiquitous computer more flexible, right? I invite you guys to check out the RFCs on Polkadot. The very first RFC that was made was by Gav, detailing agile core time, which is this way to reuse, or this way to more intelligently make available the resource of this ubiquitous computer. Yeah. So Polkadot is a network to power decentralized applications. It's also a resource for decentralized compute power. It's a self-sustainable, resilient network through its governance features. And with that, I want to close here. If there's any questions, I'm happy to take them, and then move on. Maybe we'll have like a 5-minute break. Yeah, question.
What was the pancake analogy?
Oh yeah, so gather this pancake analogy. Give me a sec. Yeah, so you've got, I'm scared I'm going to screw this up. But like the TLDR is that it's like you've got now more like imagine you have a kitchen and like ingredients to just do one thing. Well, now we can do like so many more things with eggs, milk, and sugar, or whatever. I think it's kind of like that, yeah. But yeah, check out the pancake analogy. I think there's a video about it or something. Yeah, any more questions? Question.
Can you pull up the chain thing where you could
Oh yeah, Chainviz?
Yeah. On there, like
Yeah.
green sequence, there was like 2 things that right there. So what happens if there's 2 green blocks?
Yeah. So this has to do with the finality mechanism in Polkadot. So what's happening here is, if we look at, so these blocks haven't been finalized. Now, yes. These blocks aren't finalized yet. I have a pointer. So, yeah. Yeah, so none of these blocks are actually finalized yet. Wait for it. Yep. could be a reorg. What's happening with the finality gadget? It's bugging out. Oh, okay, no. What's happening is that block authors are broadcasting a block, and validators are taking in those blocks, and those blocks are perfectly valid, but the chain actually hasn't finalized the chain hasn't added finality to the block yet. So all these blocks aren't actually confirmed. And you can see here, it says best block. So the best block is the last digits is what the finalized block is. So 75, 70, wait, where are we? 70.
That's the last one.
Oh, 75, yeah. And the finalized block is 72, right? So, yeah. So this has to do with it's an illustration of live on the network. This is all data that's being like pulled from the network, but it's an illustration of the finality in Polkadot, where you can actually, you can have blocks that aren't final yet that are forming a chain.
So, like, if there's two blocks that are not finalized yet, how, like, what's the mechanism to choose one?
For that, I invite you to read a paper called Grandpa, if you Google Grandpa consensus mechanism, yeah, Web3 Foundation research Grandpa protocol, it is the equivalent of Casper. So Ethereum has Casper as a finality gadget. Polkadot has its own thing. It borrows a lot of its research and design from Ouroboros, which is the equivalent in Cardano, I believe. Are you finding it?
Yeah.
Grandpa? Yeah.
Yeah.
What does this stand for again?
It stands for ghost-based recursive ancestor deriving fixed agreements.
It stands for ghost-based recursive
Ancestor
deriving
prefix agreement.
cryptic
Prefix agreement.
prefix agreement. Yeah, great acronyms in this space, right? Anyways, great questions. By the way, this developer is amazing. He's also created, so the guy that created this, it's totally a beta thing, but I love this visual because it kind of just, it gets to the point, right? And he's also created a thing called Chain Synth. Let's see if I can find it for you guys. Is there any other questions? Question? Yeah, question. Okay, I'm not gonna digress just now.
Okay, you always say that Polkadot has kind of high quality block space, right?
Yeah.
Is there any universal way, or what's your way to evaluate the block space which Polkadot or any other chain produce?
Yeah, that's a good question, and there's no universal way,
So no
right?
universal. It's like
So like, why would I be standing here even saying what I said? Like, oh, it's high quality.
yeah.
I don't have much grounding, but I can tell you that there's indicators that exist.
Which one?
Nakamoto coefficient is one. So how decentralized is your network?
Okay.
If this block space, if I choose to use this block space, it might, like, get back to my analogy. If I choose to buy this product, what am I really buying, right? Well, if I choose to use this block space, I know that the chances that the network goes down is much less than maybe choosing this other type of block space. High quality block space also, so goes down is to do with Nakamoto coefficient, just of the decentralization nature of these protocols. But aside from Nakamoto coefficient, you have things like how flexible is it? Like, what can I really do with it, right? Am I only using it to validate a state by using a smart contract? Or am I using it for a whole bunch of other things? Like, for example, I can let you get creative, but I'm just trying to like go through the different things I want to answer here. So flexibility, but then flexibility can also mean if I'm an application, can I only use this block space for what I need? So this is this agile core time thing, right? Whereby you can use Polkadot block space for say 3 days in a month, and you pay for just that. So again, quality is so
Relative.
what's the word I'm looking for? It's relative, but it's also personal, right? It's like, what do you care about?
Subject.
subjective. Yeah. And that's what I would leave there. It's like, you know, arguably everything is good enough. Like, I don't know, I play guitar. Like, I love Fender guitars. I think the quality is great. There's other great guitars out there that provide similar things, but it depends what I'm looking for. But that's a good question. Well, how do you define quality? I think the answer would be like, I don't know, just pay a guy that can like market it better.
Well, it's a good thing to know because if you relate other blockchains, as you mentioned, like we have Ethereum, we have, I don't know, move-based blockchains, we Aptos, we have ICP. So it's good to know like whether it's like universal way to identify maybe some
Yeah.
chains that are launching, they are kind of claiming to be so good, but they're not like nearly this that good.
Yeah, totally. I mean, this is why I like this slide, because ultimately, like, okay, like, if you think about the whole organic market, right? What's happened is that we've had now standards that say if your coffee meets these conditions and requirements, then you can have this label. It would be cool to have that for Web3, right?
By the way, is there like any limit of the number of parachains that could be operating at the same time?
Yeah, there is a limit. It's a limit that's set purposely as we're testing and stress testing, adding new parachains, and it has to do with the amount of validators in the network.
But if you increase the amount of validators, could be increase the number of parachains.
Yeah, absolutely. That's
So-
exactly it.
It's just a matter of time, as far as I understand.
Yeah.
So, as soon as I don't know, a lot of quality builders are coming to build some really valuable parachains, and there is like enough space, there isn't enough space, you'll be forced to become more decentralized, to onboard more validators, right? And
Yeah, so I'm certainly not the guy in the room that can give you all the information on the technical level of this, but the high level is that there's a relation between the validators and the amount of parachains that
Okay,
can be on
got it.
the network for it to act healthily, right? The people that built Polkadot, the obsession is, you know, what we put out there in production is top, right? Like, there's been no downtime of either of the relay chains in Polkadot history. The only downtime is collators or parachains that they messed up like a spec version, and all of a sudden they no longer receive the service of Polkadot. Like, those blocks don't get validated. So the way that it works is that you have a group of validators that are doing the work for a single block that it receives from a collator. So by that definition, by that notion, there's a correlation between the amount of validators
yeah, I
available and
understand.
parachains. Yeah, and it's set as it is because this is safe for now. Like, we're good. There's really cool technologies that are being pushed, and it's actually now live on Kusama, I think, called asynchronous backing. So write it down and dig deeper in that. If Rob is around this week, I think he might be. You talk to him about asynchronous backing. He'll tell you all about it. But it's a mechanism to have more throughput in the network, to have more parachains onboarded to it.
I guess that's what we have discussed regarding to be able to sell the Blockspace to other applications, right?
I know. So asynchronous backing is more about the scalability of having more parachains on the network. Selling Blockspace stuff is another cool thing about this new narrative, this new push for making Polkadot Blockspace more flexible, more accessible. So it's to do with, hey, if I buy some block space and I don't need it for more than 2 days in the month, I have one extra day, maybe I can sell it to someone else.
And maybe the last question, if you don't mind.
Of course.
Regarding the DAO, you mentioned
Sure.
that Polkadot's DAO is like one of the biggest ones in Web3. So, your personal opinion, is it like really efficient in terms of voting power? I mean, if somebody proposes some technical, I don't know, update or whatever, but right now your voting power is based on how big are your dot bags or Kusama bags, and you might not be that proficient in the topic, you know.
No, yeah. Wait, so can you repeat like what the question is?
Yeah, like what's your opinion regarding the DAO mechanism? Like whether it's like perfect, because I like the DAO idea, but I haven't met like any perfect DAO right now since you're rather voting I don't know, your vote power is based on your staking power or on your holding power or the mix of it, like, you know. But we become to, well, DAO is basically politics. We
Yeah.
come to whether each vote is equal to each vote, whether people that have no education about, no, Web3 or technology
Yeah.
have the same voting power as people that do know, whether a newbie has the same voting power as a guy that is like 10 years in the industry, you know?
Yeah. So the comments are about like getting my thoughts
Yeah.
on the statement that Polkadot has brought and has made to fruition the biggest DAO in Web3, which is maybe a bold statement, but I could back those claims with some facts. But the then my comments on like voting power and like how is this like maybe decentralized, because if you have people with a lot of dot, they could maybe influence things in different ways, blah blah blah. Yeah, and then also you have people that aren't really experts on things. It's a big issue. Like these are big issues, right? So they're issues, but they're being actively thought about and trying to be upgraded on a protocol level. So specifically, like we can change things like locking periods, or we can change things like we can try to incentivize dot holders to vote more. Maybe we can try to get dot holders to delegate their votes to experts. So this is actually a thing right now in Polkadot. Also, I want to say, I use the word DAO, and throughout this week and my talks and stuff, I'm deliberately trying to use words that are less native to Polkadot. Personally, as a Polkadot guy, I don't like that word DAO. It doesn't mean anything anymore. Because a lot of DAOs today, outside of, a lot of DAOs in general, there's a lot of DAOs that aren't native to Polkadot. Bear in mind that when I say that, it's a governance entity who is servicing Polkadot. Yeah, who is there for the benefit and prosperity of the Polkadot network. So it's not like, oh, it's a group of people that are doing games night and they need pizza money. But yeah, and so I want to say that there's so much stuff that is not really happening on chain. A lot of attack vectors, collusions. The beauty though with this stuff, which I would rephrase it to an on-chain governance mechanism, really, is that things can be proposed. They are literally call hashes, i.e., they get decoded into real code. That when that thing is proposed and executed, that code runs. So that code could be send 200 Kusama to do the thing.
You know, just the idea from the top of my head. Maybe.
So that's a cool thing that's different, right? Than all this off-chain talking, and then maybe let's vote on the thing and blah blah blah. This is literally you put the some data that represents code to be executed.
Yeah.
People vote, and then that thing is executed or not.
What I wanted to say is the cool thing to implement might be before voting you have to answer some questions. Like you have a proposal, and if you don't answer the questions regarding the proposal, like for example that ambassador proposal, are you sure you wanna spend KK per month from ambassador program from the treasury? You know,
Yeah.
this kind of stuff.
Yeah.
Are you sure you want to implement this code which will relate to this kind of stuff? And before like voting, people like have to answer the question, like they have to read through the proposal like attentively, and it would be like more beneficial in some way.
Yeah, those are great ideas. Yeah, cool. Well, we happy to talk more about it, and also I have some slides for the next, like officially we have another talk scheduled, which is still me. Today I'm doing a lot of talking, and the premise of that is how to get started if you want to build in the space. What are the opportunities? And actually, this is a good kind of like I do want to take a 5-minute break at least, but where you can get involved and learn about these things, because all of this stuff that you're mentioning, and by the way, thank you for your input. It's nice because I like to have this kind of environment where we're kind of asking questions together. All of these things are being discussed actively, right? Like on the Polkadot forum, on the governance channels. So like, you know, before a proposal is made, there's discussions that are off chain. People are like, oh yeah, I think that's a good idea. 10K for a salary. Yeah, go for it. Yeah, I'll support you. And it's very interesting what's happening on Polkadot right now. Anyways, thank you for everyone who's attended. Cheers.